Cool, awesome. So hello everyone, my name is Joe, and I'm a developer advocate at Dragonfly. And before Dragonfly, I was a backend developer for years. I've even tried to create my own startup. So because I was so focusing on backend, so I use a lot of databases and data stores, and I gradually become a fan of all of those good data stores and databases. So today I'm here to um, take you to the next level of as for your journey to Dragonfly Cloud. So we try to help you with your next steps with Dragonfly Cloud. I believe many of you or some of you have a Dragonfly account. So uh, if you do have, that's great. And if you don't, then don't worry, we'll get there like very well, very quickly as well. So cool, let's get started. So first, for the newcomers, right, I need to touch just a little bit in terms of what Dragonfly is, right? So Dragonfly, um, we like it's an in-memory data store mainly, right? So why we built Dragonfly? So because we saw problems with Redis, right? So the main drawback we consider for Redis is that it's a great API, it's a great data store, it's great. It's just that it's written 15 years ago, right? So some of the design decisions by then um, is makes total sense, right? So, but the main drawback for today is that it is utilizing only one cores or one core or one CPU core, one processor on your modern cloud servers, right? So the rest of them are kind of wasted. And if you do want to utilize all the CPU cores on your hardware, you kind of need to run a Redis cluster, right? So you're running a distributed system on a single machine. So we see that problematic, right? That's why we built Dragonfly. And as for Dragonfly, it's built from the ground up. So it is using a new multi-threaded sure nothing architecture, right? So basically means that if you take the binary of Dragonfly and you put it on that 64 or even more cores machine, it is able to fully utilize all the hardware that you have, right? So it scales vertically first. That's why we built Dragonfly. And we, from the community users and our benchmarks, we observe like over 25 times more throughput on a 60 core AWS machine, right? And but we don't change for the sake of change, right? So if we look at Redis, there's always like good parts and some like stale parts, outdated parts, right? So we consider the underneath architecture to be stale, and that's what we want to improve. So it has like a more powerful architecture underneath, right? But for the good parts, the Redis or nowadays Volky, the API is awesome. Developers love it. I love it myself. It's like very easy to use API, super powerful, good for caching, good for like other rich data structures as well. You can utilize in your backend code, right? So we keep the API. So Dragonfly is designed to be compatible with Redis or Volky. So the API is the same. Often the only change you need to do is to switch the endpoint in your application code, right? But the rest of the commands and everything, they're the same. But now you know that you have a much more powerful engine underneath. It's kind of like this, right? It's kind of like two cars, right? They are almost identical. They're probably, exactly the same when you drive this car. Nothing changes, right? But you know that the engine underneath is much more powerful. And so it doesn't change how you use it, doesn't change how you drive. But as I said, the throughput is much higher and the latency and the snapshotting speed, we focus on efficiency and performance. So yeah, that's a little bit introduction of Dragonfly, the project itself. Next up, obviously Dragonfly Cloud, as you can guess or imagine, it is our cloud offerings, our cloud service, right? It's made by the builders behind Dragonfly. So Dragonfly Cloud uses exactly the same code as what we have in the GitHub repo that we have. So we don't have any like gated enterprise features or anything, right? It's just like it's the same code, but we take it onto the cloud and we do all the provisioning, auto provisioning, scaling, monitoring, and all the other features. Those are handled for you by us. Right? Yeah, that's basically how what Dragonfly Cloud is. Awesome. Currently, we're on like all the three major cloud providers, AWS, GCP, and Azure. And yeah, we recommend all our customers running Dragonfly in production to use private networks because it's more secure, it's faster, and it reduces the the data transfer cost and latency because it sits right next to your application code, right? We support other features like snapshotting to cloud storage like S3. So you know that you're safe if you're, if you need to, if you ever need to store and reload the backup. We also provide very comprehensive monitoring dashboard and Prometheus endpoints that helps you, to have a safe mind that you know that your Dragonfly data stores they're healthy. And recently, we also launched the IAC support specifically for Terraform and OpenTofu so that you can manage your uh, Dragonfly Cloud resources using code, using configuration files instead of clicking in the UI, right? So that's preferred by many of the DevOps teams as well, so that yeah, you get track of all your changes of your Dragonfly resources. Yeah, using the Terraform configuration files as well. We also, the scaling process is very simple. I'm going to show that as well. And at the moment, Dragonfly is a like when you provision something on Dragonfly Cloud, it's a dedicated service. So you get your hardware. It's not serverless, so it doesn't automatically scale like to zero or to infinity. That's not the case right now. And we made this choice because we think dedicated when you have like steady or steadily increasing workloads, that's the best choice so far. So, but in the future, there are possibilities for other type of services as well. Cool. And finally, I want to mention that we also have our own clustering solution, which is called Dragonfly Swarm. It is automatic. It's very premium. It's a great service. It's a great offering too. So we see teams replacing their Redis cluster with a standalone Dragonfly instance. So a standalone Dragonfly can replace a Redis cluster, right? Because it can scale vertically, so it uses all your resources. But if you need more than that, if you have like super demanding workloads, we do have our clustering solutions to shard your data set into multiple Dragonfly instances as well. And we were able to go, actually, it's very impressive. We actually can go above 100 terabytes of in-memory data and more than 100 million QPS, right? If you really need that, then we're here for you. It's kind of like an extreme case where you have like super high workloads, right? But like Dragonfly is very trustworthy for a standalone, and when we shard it, it performs like um, very well on each of the shards as well. So we scale vertically first, and then horizontally. And each of the distributed machines, they run only one binary of Dragonfly, right? As you can guess. So it's a very powerful system we have. That kind of concludes my introduction of Dragonfly, the project itself, and Dragonfly Cloud, what we're offering. And let's see if we have questions here before we go to the next step. Right. All right. So I see one comment that's very interesting, which is about yeah, we do not have large caching requirements, but we value redundancy. So I assume adding a replica is the first step. Yes, both the community edition, like Dragonfly itself and Dragonfly Cloud, we support replications, right? And in one of my past sessions, right, like Dragonfly can I will just give an example here. Dragonfly can even replicate from a Redis instance. That's how compatible it is, right? So when replication happens, the first step is to take a snapshot and then gradually streaming the upcoming, like the subsequent write commands over, right? So that means that Dragonfly is able to load a Redis snapshot as well as, of course, accepting like subsequent write commands. Right? So yeah, and that's great. Let's move on to the next slide. And yeah, as we've seen enough slides, and it's always exciting to see the actual demo. That's what I'm gonna do today. So yeah, just give me a second to move my few windows around here, and we can continue. So yeah, I'm sharing my screen right now, and let's head to um, Dragonfly Cloud and see it in action. So yeah, so I'm on the Dragonfly homepage, and it's dragonflydb.io. And up here, we do have the sign up and login process for Dragonfly Cloud. It's quite simple. It takes you, if you have an account, you can follow along. If you don't have an account, maybe sign up right now as well. It's very easy to follow. Cool. So I'm gonna be logging in with my account over here. Cool. So I'm logged in right now, and as you can see, we have like three like major tabs up here, right? Like those are the important resources, like the first class citizen resources, we call it in Dragonfly Cloud, and let's run through them like very quickly one by one. So first up, let's start with the account, right? So account is a place for you to manage your team within Dragonfly Cloud, right? So you can manage your users, API keys, or backups of your data stores, and you can see usage and billing as well. So it's just a place for those like housekeeping stuff. And networks, they're very important as well. I'm not demoing network today, but I do need to emphasize like why the importance of networks, right? So networks in Dragonfly Cloud means private networks, which can be used to connect to your cloud provider, for instance, GCP, AWS, or Azure, right? So when you create private networks and when you have like when you create VPC, like virtual private cloud in your cloud provider, and then we establish the peering connection so that the Dragonfly data store can be connected directly within the private network of your cloud provider, right? So there are many benefits of doing so. We definitely recommend anyone running production data stores to use um, private networks and peering connections because first, it's more secure. It doesn't go to the public network, right? And it's faster because it doesn't jump like through a bunch of hoops of like the public routers, right? Because it's routed within your private network. So it's more secure, less latency, it's faster, right? And also by doing that, maybe you can consider disable TOS as well, because like it's secure enough so that probably you don't need the TOS. TOS, it may sound cheap, not very compute intensive, but we're talking about millions of operations per second, and each one of them is having like a sub millisecond latency. We're talking about a scenario like this, right? So not having TLS also kind of boosts your performance and latency as well. And then finally, we have this data store, which is like the main resources we have in Dragonfly Cloud. A data store is backed by one more Dragonfly instances. And yeah, depending on your setup, like with replicas or like Dragonfly Swarm, we will use one or more data stores. Right? So today I'm gonna show you like how to create one or two of those and see them in action. Right? So first, let me hit the class data store over here or here, the same, because I don't have any data store here yet. And Now I can just give it a descriptive name. Let's say Go um, df standalone. Go away one password. I love one password, but yeah, it's in my way. Yeah, we can pick the cloud provider over here. And for this one, I will create a single shard, like a standalone Dragonfly instance. Right? I will do a 3 gigs, just to as a development, just to try it. We can scale it later. I will show that as well. And because it's public, so we recommend to enable TOS for public endpoints, right? And there are just a few like configurations, as you can see, the whole configuration, you know, is just like one page on the website on the console. So it's totally very easy to do, right? So from there we can review and create. Cool. So normally this takes 1 minute or two. The maximum I've observed is like 3 minutes, right? So it's quite fast compared with many of the existing solutions, I have to say. Some of the providers I tried myself for some testing and blog post purposes, they take like half an hour. I don't know why, but it's the reality and kind of weird in the modern cloud era as well, right? So while this is running, let me create another one just to showcase another data store, same cloud provider, same region. I'm going to name it JoeDF Swarm this time. And I will pick a Dragonfly Swarm cluster, which is multi-sharded, right? So this is, as I mentioned, it's our clustering solution. As you can see, the memory size get bumped. So we start with 100 gigabytes for this setup and goes up to 2 TB. The 2 terabytes is not the max. It's kind of like a soft max. We try to prevent our users and customers to over provision accidentally. But as I said, we do support over 100 terabytes. If you need that, then please contact us. We can customize that for you. Um, yeah, I will keep it as 100, which is like already huge in terms of in-memory disk store if you're using as a cache, right? I will keep the standard compute, and yeah, these tiers they have the same memory size, but we increase like more CPU cores if you have like very CPU intensive tasks. For example, if you're using sorted set, when you insert an item into a sorted set, it keeps the order as well, right? So yeah, data structure algorithms, it's very CPU intensive to make sure that it's inserted into the correct place. Awesome. And I will leave the rest of the configurations default as well. All right. As you can see, we have two data stores right now. One is a standalone, one is a swarm. The swarm is still running, but the standalone one is already ready 2 minutes ago, right? So we can try connecting to it. So the yeah, the easiest you can do is to grab the connection URI that I have over here. I'm just gonna take that and then switch to my terminal, and I can use the Redis COI. That's a COI utility to work with Redis compatible APIs, in this case, Dragonfly data stores, right? You can use other things like Redis Insights. Most importantly, your backend Redis client libraries, those can be reused with Dragonfly. So yeah, I'm here and let me paste in my data store URI, and boom, I'm in here, right? So this is a brand new data store, so it shouldn't have any keys, but I can start to issue um, Redis commands that you're familiar with, right? So it's exactly the same how you use a Dragonfly data store. Uh, yeah, and I can give it like more information. Maybe I can run the info server command, right? So you can see that this is the Dragonfly version we're running. We also keep some of the Redis output as well, just so that the client libraries may need this type of information to yeah to identify like what's it's connected to, right? So yeah, that's our standalone data store. Let's go check our Dragonfly Swarm one. It may take a little bit longer because it's a sharded cluster. So let's give it another minute or two. Oh, cool. It's ready as well. So now I'm gonna grab the URI of this one, right? So as I mentioned, Swarm is distributed, right? So it's a multi-shard, but it gives us only one URL here as well, right? Because when you connect, we do have a centralized control plan to direct your commands to different shards, right? So, but from a developer's perspective, like why complicate things, right? We should simplify things. That's why we provide only one URI in this case, and you can just use that to connect to your Dragonfly Swarm. Let's try that too. So here I'm in the previous standalone one. Let me exit out of it, and I'm gonna do Redis CLI dash u again. But this time using the new URL for the Swarm data store, and I'm in here again. So this time I will just run some like cluster information command, right? So you can run cluster info. You can see that this Dragonfly Swarm multi-shard cluster is backed by four Dragonfly instances underneath, right? A similar command would be cluster slots, where you can see that each of the shard instance is assigned, certain range of the key slot, the hash slots, which determines like what kind of, when you have a key, where does the key go? And when the key falls into one of the ranges, it will be on this shard, right? So you can tell that it is four of them, right? So why four of them, right? Again, if we can make things simple, why we don't need to complicate it, right? So um, because we manage and run Dragonfly instances a lot, we kind of have our mechanism to determine like what's the best number of shards to use for your swarm. And yeah, that's basically why. So the only thing you need to care about is like how much memory you need. And if your task is like super CPU intensive, maybe consider increase the compute tier, right? But other than that, how many shards to use and if you scaled it, if I scaled it to like more memory, it will change like the number of shards. We will migrate your data over and change the number of shards as well. And but all those should not bother you, right? It should like bother us. We determine what's the best number to use for you, and you only care about your organization, your business, right? Like what's your use case? That's the thing that you should care about. You should care and leave the rest to us. Maybe we can try that. Maybe I can try bump this from 100 to 150 and give it some time, right? So it will be updating the data store. Cool. So yeah, I just showed a very basic example of using Dragonfly Cloud. Let me bring my slides up again. Just 1 second. It's a basic example, but I try to emphasize like how easy it is to use Dragonfly Cloud, right? I was using the console, so you see what's happening in the UI. But if you use Terraform, it's the same deal. We have configurations that maps to the UI configurations like one by one. So you fill in the values, you get a data store that you like. So yeah, to me, um, it's a very lean product, but I think simplicity. I like the Go programming language as well. Like simplicity is complicated, right? So um, that's why we keep things simple, and we don't want to confuse our customers. And when you use Dragonfly, you should feel that it's so easy, and you know that it's powered by the much more powerful Dragonfly engine underneath, right? And you use the same Redis commands as always. Cool. So that's the demo for now. And maybe we can switch over to see when the 150 Dragonfly Swarm upgrade is ready. But in the meantime, let's see if we have questions right now. And yeah, and you're definitely welcome to visit dragonflydb.io for more information. All our information, like the docs, the project itself, they're on there, and dragonflydb.cloud if you want to sign up. And or if you already signed up and you want to try what I just showed, that would be great, right? So, okay, here I have a question with Dragonfly Swarm. Do you need to wrap identifiers in curly braces to ensure they go to the right shard DB? We use the Laravel stack. There's a node that wrapping the queue names. Yeah, that's a really good question. So when you wrap a key in for Redis or for Dragonfly, they're the same deal. Like they are called a hashtag in the key, right? So um, what happens normally if you don't use that is we're gonna compute a hash of your whole key, and we decide where the shard where the key should which shard the key should reside, right? But if you use a pair of curly braces to wrap that a portion of the key, then when we do the hashing, we don't look at the whole key. Instead, we only look at the hashtag portion of the key, right? So yes, it's a good practice if you want to control, if you want to make sure that certain sets of key resides on the same shard. So to answer your question, for both Dragonfly, because a single Dragonfly instance also kind of can emulate a Redis cluster, right? So let's say if you use standalone, we also need to determine which thread is multi-threaded. We need to determine which thread in that Dragonfly instance handles that key, right? So it's definitely a good practice for Dragonfly when you use, say, BoomQ or Laravel Q, and you need to make sure that the queue names, yeah, the queue name will, so a queue in those systems could imply multiple keys, right? So you want to make sure that those multiple keys are residing on the same thread of Dragonfly or the same shard of Dragonfly Swarm. So yes, it's a good practice to do that. Thanks for the question. Cool. Let's see. We have more. Yeah, recommendations for variable command. We have some seasonality for our business. Can we scale up and down via the dashboard? Yeah, that's a good question. So maybe I can show my screen again just a little bit, present. All right. So as you maybe remember, I'm just refreshing. I bumped my it's still updating. So basically, I bumped my Dragonfly Swarm from 100 gigs to 450. Right. So yeah, that's for Swarm. But for standalone, you can do the same thing. You can come to your data store and you hit edit. Right. I provisioned a 3 GB development instance just to showcase. But let's say you're ready for a bigger one, you can just do it over here and pick your compute tier as well. So just a few clicks or just a few configuration change in Terraform. Yes, you can scale up or down your Dragonfly data stores, no matter if it's standalone or if it's a Swarm. Yes, it's just like at the moment, it's not automatic because we believe that like if you're using a cache, it means that your traffic is already like constantly busy to a certain extent, right? So we don't have like automatic scaling or serverless scaling at the moment, but yes, you can just change the configuration and save it, and your data store will be ready. And during the process, we migrate the data over as well. So it's like technically zero downtime if you're using a client library, right? Normally the client libraries they have connection pools, right? So the connections would be dropped and recreated, but because it has like pooling, so you don't feel it, right? So the disconnect and reconnect process normally you see it for like maybe 2 3 seconds, but that's it. Your library should handle it automatically. And then your data is migrated over to the bigger instances as well. So yeah, zero downtime scaling. Cool. Let's see if we have more. Yeah, we kind of hit the time mark, but I'm so happy if you have more. And if you're shy right now, please join our community as well. We have Discord and forum. Everything is on dragonflydb.io. Yeah, remember to check it out. How to integrate Dragonfly with Laravel, Vapor, and Cloud? Oh, that's an interesting question as well. So I guess. Yeah. So Laravel Vapor, to my knowledge, it's a serverless environment, right? So the goodies about serverless is that it goes down to zero if when you don't need it. It's kind of like one function by one function execution, right? So it's like very resource efficient, and you pay only the times of function executions. That's kind of the higher picture. The drawback is that within your code, you probably cannot have persistent connections, like persistent TCP connections to Dragonfly or pools, right? So each of the requests needs to be sent like one by one and authenticated one by one too. So Dragonfly does support an HTTP endpoint, which you can issue data commands as well. So you send, each of the commands like get within an HTTP using JSON, and also authenticate. Yeah. So yeah, we do have support for that. It's at the current stage, we would consider it's basic right now. But yeah, there's possibility that you can use HTTP based, let's say stateless client connections to send commands to Dragonfly as well. Awesome. And I do have a comment I want to share to confirm Dragonfly works really, really well in Vapor. You just cannot use for caching of queues. Okay. So I'm glad there's a it works really really well for maybe like part of it like depending on the integration, right? So we consider ourselves as part of the Redis Volkey API compatible ecosystem as well. We're actively integrating with third-party frameworks that utilizes the same API like BoolMQ, like Sidekick. So yeah, maybe the next would be to focus on the PHP community a bit more as well. Because it's highly compatible, normally what we do is that we just do a compatibility test, and then we make sure that the performance is retained, right? Like a good example is using the hashtag in key names so that Dragonfly performs the best in that scenario. So yeah, we will continue doing that. We're proud to be part of the community, and yeah, we'll keep the good work going, I think. Awesome. So yeah, that's it from me today. That's all the slides and demo. I hope it's informative to you. And please do visit dragonflydb.io for all the other information and dragonflydb.cloud if you want to try Dragonfly Cloud. And this is our first time doing this series, so we plan to do this more. This is the first time, so I just showed like the very basic but simple, seamless usage of data stores. In the next ones, we may show like private networks. Let us know what's the most interesting topic, what you want to learn more about Dragonfly Cloud, and we can definitely accommodate that. Thank you so much, and we'll see you next time. Have a great one. Take care.